notes for whatever reason. It's your own personal choice, I suppose, but you could be looking at your notes. I just told you. Just go back to 6.4. If you're organized, you should be able to find it real easy. It's all right. Somewhere. I know you at least know where to look. What part? The coefficient, the exponent, or the base. Which one should you be looking at to answer the first question of growth or decay?
Second one.
Third one.
Hold on. Ready? Let's get the terminology, the vocab down. Go. Coefficient, the number in the very, very, very front. Exponent, what's going on up? Or base? Coefficient? What do you guys think?
No, it's the initial amount.
Trey's pretty confident. What do you guys think?
Yeah.
Look at this base. It's the one that's telling you. Look at this base. What's being raised to the power, to the exponent. And then think about one little fact. If it was a 1.00, that means 100%. AKA stays the same. Multiplying something by 1, it stays the same. 100%, you have what you have. It's not changing. It's not different. That's the first question. The second question is, how much does it change from that original, from that reference point, from that 100%? Okay, everybody shh, and give one more minute to everyone thinking. And label each one. Is it a growth or is it a decay? What do you think? Because remember, it's something to use to study from. Label each one, growth or decay? Yeah, right? Is it certain? Some light bulbs are going on in here in a couple. Is it above or is it below? Is it growing or is it shrinking? Is it swooping up or swooping down? It's been a while. Adrian, I love that you've written that. The problem is there were 2 questions. The second one says by 25%. What? Adrian just gave an answer, but maybe it'll help you finish the other 2. He just said growth. Now, technically, not just any growth, but exponential growth. Adrian, I'll let you claim it because you did a good job. You said growth by, and what did you answer? 25%. He was absolutely right. He gave the answer away, but now maybe some of you can use it to do the second and third one. Growth or decay? And by how much? If you tell me growth or decay and by how much, you've just finished.
Oh, yeah.
Some of you, the mental math might be a little bit sticky. All right, 15 more seconds. Five, 4, 3, 2, and 1. Number 16. Growth or decay? Grow. However, yeah, good. By 6%? Love it. Because it's 100, well, it's 1.06, but 106, right? And then decay, ooh, do you guys get that subtraction?
16%.
Okay, now hold on. That's excellent. The numbers and the growth and the decays. Excellent. But pause, come back. What makes this an exponential growth. Because lines can grow, or lines can decay. Parabolas can, okay, awkward, decrease and increase. They kind of do both, or increase and decrease. They do both. But what in the equation makes this exponential, which is really important for the last section in chapter 8 for us before we get to the final review? It's all about this. Say it louder. You were totally right. It's all about the exponents. Oh, it's not working for me. Sorry, I'm trying. It's all about the exponents. I'm going to try to get a highlighter out so I can highlight it. Do you guys still have your colored pens? Oh, so many of you only have pencils. Come on, I can use it to study. How did you remember what to do? Because you guys aced the second one and the third one, but you guys were kind of struggling, most of you, on the first one. So, Adrian got the first one, but what should you write yourself down to review these types of problems? Set the middle or set the... What's going on? Close it. Put it down. Give it to me. Thank you. And stop distracting everyone around you. Okay. I apologize if they were the ones that were distracting you. Jeremy, you know exactly what tissues are, so be an independent student. Go back to my desk and deal with it, okay? I'm sorry that you spilled it. I'm not sure why you were taking things out or putting things in them. Because you had ice cubes in your hand. I don't think that was the proper way. Oh, okay. Got it. Thanks, Ben, for explaining. I appreciate it. Now, what am I thinking you should be doing right now? Having a colored pen. Most of you just have pencils. What do I think you should be doing right now? Writing yourself notes to study for the final. I can't force you to do anything, but I can give you wise counsel, okay? Jeremy, it's okay. Deal with your problems. You don't need to be looking at anyone else. It happens. We all spill water, okay? So, right now, I'm going to go ahead and highlight this idea of exponential. And if I were you with my colored pen, what I would be writing is exponential growth and decay. How do you know which one? Adrian kind of helped us. He said look at the middle. I'm going to say be careful. I'm going to say look at the base. Because this one, unless you realize there's a 1 in front, you might not realize there's a middle. So I'm going to say look at the base and compare to 100% or 1. And ask yourself above or below, right? Growth is going to be above 1 or above 100%. And decay is going to be below 100%. And then, you guys needed a reminder for how to do this. It's snazzy vocabulary, percent rate of change. Remember? You have to subtract or find the difference. Maybe that's a better way of putting it. Find the difference from that 1. Or 1.00 if that helps your brain just a little bit, right? Adrian found the difference. He's like, oh, it's 25 away. 0.25, but yeah, 25%, right? Move the decimal 2 places. You guys figured out it's 6 away and it's 16 below. Got it, got it, got it, done, done, done. Are these supposed to be super hard? No, but you have to remember how to do them. Yes. Does that make sense? Cool. All right, final review. Whew, that was an easy one. As long as you've written those notes to yourself for section 6.4, you need to go grade that homework, which I heard was also an easy one, which is awesome. But we need to point out a couple things that need to be memorized by tomorrow's quiz. Quiz tomorrow might be easy, but there are a couple things to memorize. There was a question. Jonathan, Andrew, Anderson.
I was going to say, are you going to give us like an actual study guide to this, or is like the kind of review study guide?
Next week we're going to have things like practice assignments, which I could do like a topic study guide if that would help.
You know, we like to have like a no card.
Let's get to the quiz. And then we'll talk about it on Monday. Alright guys, here you go. Numbers 3 through 11, you had some evens. Number 19, it wasn't an even, but the poor little program online, it doesn't know what to do when I give it one problem. It shows it every single time. So your homework is open and you are grading. I see a lot of zeros right now because you're not showing me that you did your homework. Open up your homework if you have it. It's the one back here on the board, page 436, homework number 38. I know that, but I love that you have a question. Just hold on. This homework, raise your even real fast. If you have it out, I can give you credit. If you don't have it out, I can't.
I'll be honest, I ain't doing it.
I sent you like 2 times.
That's
$2. That's $2. That's $2.
It's insane.
That was such a waste of time.
I thought it was I was looking at you.
Hey, what's up, Dre? How you doing?
Oh, where's my grab?
Wait, for the new one? You have to grab.
You have to grab.
Yeah, he went to play. She wants to play.
Bro, I put it on Jaw.
Jaw's dead.
Oh wait, no, we didn't have to grab. Yeah.
Why were you born behind this line?
Hey. Yeah.
And then you're answering about this question.
Yeah.
Good job.
Oh yeah. Okay. So there's like formula after this. It says act like on the axis of symmetry. You have to do that by using this formula. So B is the second number in this equation, and then A is the first number in this equation. So it would be negative. And 2.
Just like
and what I didn't get, which is 4 plus 3 equals 1.
Yeah.
So like, wow, you have the extra negative, so it's power.
I'm too small.
No, 2 times the class.
I'm too small to do that.
No. Yeah, it is, but like, we're not worried about it. We're just worried about the number. Yeah, that's how you find and then you didn't even ask me.
Alright, guys. Thank you for letting me grade homework really quickly. Isaiah, you can keep going. You're doing a good job, bud. Here's what I want you guys to do to summarize before we move on today. Okay? Some of you had some questions, especially starting right around here, if you didn't realize there was a really nice formula to use. So I'm going to go ahead and open up notes from yesterday with the homework that's right here. I have so many things open. Okay. Yesterday, we talked about an important formula. And some of you got it, and you were like, homework is easy because of it, and some of you didn't. So let's go ahead and do a quick recap of yesterday before we move on today. Because, guys, check out this page. This is the beginning of the end of section Okay. I know some of you, it's really hard for you to possibly listen to a teacher if they're not staring you in the face really awkwardly because they're frustrated that you're still talking. Now, I know that Isaiah and Armando are talking in the back, but do you know why? They're helping each other. Okay. So here we go. Up here on the screen. It's okay. I know we have a lot of maturity issues that we deal with, especially in 9th and 10th grade, but we're just working on it, okay? We're supposed to be doing this to finish section 8.3, but from homework last night, I'm going to summarize what you're doing because there were a few people, and even for those of you that got it, you need to realize what you need to study for tomorrow. On tomorrow's quiz, if I ask you for an axis of symmetry, quick summary. You need to know to make it x equals that really snazzy, oh, come on, somebody had to have it memorized after doing it like 6 times last night. Levi, what is it?
B.
Negative b, all over?
2a.
2. Good. Negative b all over 2a. I'm seeing it because there's a bigger formula that has these pieces. It's kind of hard for you guys because you don't know the bigger formula, most of you. Yet. I know. Good. It's coming. And it's bigger, it's longer, it has more stuff, and there's a song that goes along with it because it makes it easier. But for right now, I'm just going to have you do all over 2a, that part. But we have to know who's all over 2a. And for right now, it's negative b. Axis of symmetry. For all that homework last night, starting in number, can you guys tell, number 6? 6 or 7? You had to plug into this formula. 7. Cool, good. Number 7, you had to plug into this to get the axis of symmetry. But that wasn't the only thing they were asking. What else were they asking for? Yeah, but the nice thing for the vertex is it's just a point. Except the point needs an x. Oh, don't worry, we just found the x. The nice thing is you get to steal the axis of symmetry x. Same one, same formula. But the problem is you weren't done. So my ones that did figure out how to do 7 and 8 and 9 and 10, 11 was different. How did you finish the point? Plug it in where though, Max? Back to the original. Good. Because at the very beginning of the problem, you are given some sort of quadratic. So to get the y, you have to take your special axis of symmetry x, which some people actually call it, and I know it's weird, but x is so general, like it's used all the time in math. This special guy, the vertex x of a parabola, a lot of people call it h. Because in future math, the vertex is given a special name. H is the x of it, and k is the y of it. It's like the special x of a quadratic. It's not the height. I wish there was like an easy word for the h. You could be like, hey, it's the vertex. I don't know. It's an h. It is what it is. But just to help us out, we can go ahead and put that h and say, hey, whoever that guy is, put him there. But down here, I'm going to have to go back to that original quadratic and say, I need to plug in the x to find the y. So last night in homework, you should have used that little formula to fill in your axis of symmetry and then been like, yeah, I got it. Hey, there he is. But then to get the y, we have to go ahead and take that little guy and plug him in and solve. Now, I know this is kind of like, there's a lot going on, but it's only because I'm keeping it general to give you something like a model that you can use. So let me go ahead and pull up the homework again last night, because this was necessary for these guys right here. Now, how easy were 3 and 4 and 5 and 6, though? Hopefully not too bad, right? Because when you guys graded number 4 and you got that the answer to the vertex was -3, 2, you just had to find it in the graph, yeah? But if that's my vertex, -3 and 2, then what was my axis of symmetry? The exact same thing as the x. And so that's why the answer for the axis was x equals that -3 folding. Now number 6, you guys graded and got -1, 1. Just look at the graph and get it. But then once you have that point, you can steal that x. You can go either direction. Look, my arrows are both. You can say, oh, the axis of symmetry is x equals -1, the fold. So is this a good little idea to summarize last night's homework? I hope so. Because you can use it from the graph, or you can use it for these problems down below. Now number 11. Oh, Why is that so low? Sorry, guys. It's a great picture. 7, 8, 9, 10, and 11. And Hannah, this might help you out too. And anyone else that got stuck. And Jerry, make sure that you're good, just because you didn't have your homework to grade with you, yeah? If I was trying to do number, what was the hardest one? 7, 8, 9, 10, 11? Did anybody have a particular one that they were like in? Yeah, 11. Why, Adrian? Fraction. And so if you had a question of like, how do I do 11? Well, let's answer that homework question as we practice what we just wrote down about axis of symmetry and vertex. The directions. Find the axis of symmetry. And if it helps, I mean, some of you are kind of lazy. You can do like an axis of symmetry. In some math classes, they do a lot of like abbreviations. But I want to make sure that you guys know what you're doing. So I have the little clue right over here, but we can go ahead and write it. Maybe I will abbreviate. X equals. All right. We have a formula. It's not a big deal unless the numbers get close. Who's my B? Did you guys all write down -4 when you did your homework? So a -4 is going to be a +4. Okay, because a negative times a negative is a positive. But I also have all over 2a. But what's the struggle as soon as I go looking at my a? It's a fraction. Okay, now hold on. We don't need to be afraid of fraction multiplication because we can always make the other guy a fraction too, and then fractions just go straight across, right? So we can rewrite this. I know it's not super pretty, but we can actually rewrite this to be 4 over 5. But some of you still were like, I don't. If you had a calculator, couldn't you do 4 divided by? Well, most of you don't know what 4/5 is as a decimal. It's 0.8. You could also do some things with parentheses. It gets a little bit sticky, but we're going to talk about how to finish that as soon as I get back to this question. Oh, like these ones, like you simplified? Yeah. Totally legal. Yeah, that works too. Let's see if it ends in the same spot. It should. But you still would have had a little baby fraction down there, right? Okay. So with your fraction and with my fraction, what we're going to have to do is remind ourselves how to do division of fractions. Guys, it's 4 divided by. Did you say that? Did you use that vocab? 4 divided by. Some of you would say 4 over. 4 divided by who or what? 4/5. At this point, all you got to do is remember dividing by a fraction from middle school math is multiplying by the reciprocal. Remember that? So I can just say, oh, sweet, it's just 4 times 5 over 4. Now, some of you are still kind of freaked out until, oh, okay, it's fine. I have 2 fractions. Make the 4 over the 1. What's 20 over 4? Or, don't those 4s reduce? 20 over 4, or reducing the 4s, you get 5. I know it takes a little bit. And I was showing the steps very, very clearly. But coming back, Max did have a good point. You could have way back here. You could have seen that 4 over that 2 and been like, hey, those reduce a little bit. I mean, it doesn't help a lot, but it does take off a little bit of work. Okay, now with that, we have our axis of symmetry. Got him. Vertex. Check out the arrow. This is what to study for tomorrow. This is what to memorize for tomorrow. All eyes should be up at the front because it's what to study for tomorrow. It's what to memorize for tomorrow. We have our homework quiz like normal for Friday. Sunny, can you just right behind you? Thanks, Lynn. And tell them what's going on as far as what to study for tomorrow, the homework quiz for tomorrow. Should have memorized for tomorrow. Got it? Okay. How do I start filling in my vertex? The first part's easy. All I gotta do is write a. Why? Ah, they share. Look at the arrow. It's the same thing. You don't have to do any extra work. Oh, but as soon as I have the 5, where else do I need to finish my point? Plug it in, plug it in. Who do I plug it into? Okay, it's going to be a little messy, but we can do it. Y is equal to 2 over 5. Just follow PEMDAS. The 5 goes into the X spot. The 5 goes into the X spot. We just got to do PEMDAS step by step. PEMDAS tells me what to do first. 5 squared is what? So I can rewrite this as 2 over 5 times 25. Hey, don't get stressed, over 1. I can do that. Minus. PEMDAS would tell me to do what next?
Multiplication.
All the multiplications. Don't I have 2? I can multiply this to be 50 over 5, or I could reduce to be 1 and 5, and either way I get what for this? 10, yeah. Minus another multiplication, 20, and then an addition. I know it's getting a little bit rough right there, but then we can say 10 minus 20. Remember, we just add or subtract left to right. 10 minus 20 is negative 10. Negative 10 plus 14 is... I should box the vertex, sorry. Bigger box. There we go. So, what do you have up here? A homework help on one of the nastiest ones as far as plugging in, but also a page that summarizes the big ideas from last night's homework, axis of symmetry and vertex. We'll start first with one.
So the axis of symmetry, like the answer part, is the entire answer for the little equation, right?
Say it one more time. The axis of symmetry, and making sure that all the words are.
Like the answer that would be for the negative b.
This is where it came from, yeah. The negative b, all of it. And so that's what I did up here. I started with my little baby formula, and whatever that answer is to the formula is just what I write down, x equals for the axis of symmetry. So do you see it? This was me doing that, and then I got to just go ahead and plug in.
You just pull it a from like the actual equation.
Oh, yeah. So my a is that first guy, ax squared, and then my b is this next guy, bx, and then my c is the last two that I don't need yet. Probably like just like in homework, there's usually like 1 or 2. Probably just 1.
How do you get the axis of symmetry?
Oh, the axis of symmetry came, now, this one was hard, Danny, because there was a lot of work. I went from here, do you see how this is like this formula? So I took the B, and I took the A, and I plugged in. Now, I had a lot of work to do, a lot of simplifying. It actually went down. What happens in that formula, what results the answer, is what goes into the axis of symmetry. So the axis of symmetry is always x equals, do this, simplify it, take the final answer.
So do we get what's from the function and then we put it into the equation?
And then you simplify that all down. Good. And if you can write yourself a note about that, it'll help your brain kind of be able to study it. So then once you have your axis of symmetry from the formula, from solving, this one just took some time. Then we get to put it right in there. And then we just have to go ahead and plug it in and simplify. Okay. That was last night. That was number 11. A few of you guys, I think, just forgot to go to number 19. I'm not sure if it was necessarily like awful. We can still peek at it if you need to. Was there any other homework questions that you guys needed to talk about? Okay. Number 19. What was the error, guys? What was the problem?
They didn't have 2 negatives.
Oh, yeah. It was a negative 12. It was supposed to be a negative. So they just kind of stopped. They put in the negative 12, but they didn't write the negative in front. That negative in front would have made it a positive. Got it. Okay, so let's see what on earth is extra, what on earth is additional to finish off section 8.3. Getting back into our notes, I told you guys, wrong one. Those are calculus notes. There we go. That you get to practice the axis, symmetry, and vertex. Now, Max, you were like, hey, are there fractions tomorrow? I said, probably just one. But let's do another fraction one to practice. Okay? So in your notes, out of your homework, this wasn't a homework problem, this was your notes. So this goes in your notes. Axis of symmetry. Vertex, there's going to be one new thing showing up. Y-intercept. We talked about it a little bit yesterday. I don't think homework made you really do it a lot. So go ahead and use these formulas. Use what you just did in homework last night, or use what someone explained to you to practice for tomorrow's quiz. So we're in our notes. Starting off and practicing that skill that homework needed last night. You guys doing that 1/2 okay? Are you dividing by the fraction, multiply by the decimal, plugging into the formula? Jeremy, hold up your work. How's it going?
Just follow directions.
Okay. So that. Shoot.
I'm not doing that. You're not doing this? No. Well, good. The essay? Yeah. What? Yeah. Essay. You want to do my essay?
I do last 2 maps.
Come on. You know what it is? Do it at home.
You guys have been working on this problem. I see that Adrian has a question. I just want to give you a chance to not be bored because, well, you might have gotten stuck with that negative 1/2. Hopefully all of you are starting with that negative b all over 2a thing. And hopefully that negative b, you put in a negative 3. You guys do 2 negatives that make it a positive? All over 2 times. What went into the a spot? Is it 1/2 or negative 1/2? Negative 1/2. Yeah, no need to be stressed about that 2. Just put it over 1 and the 2's end up going away. Negative 1. Good. Which actually, doesn't that make this easier than the one we just did?
Yeah.
Because this one will be a positive 3 over a negative 1, which is a negative 3, right? So x equals, what goes in that x equals spot then? So what can I automatically bring the arrow down, put into my vertex? Negative 3. But what did you have to find next? Your y. So where did you guys start plugging in that y? Well, you got to go look at who is this guy's function, right? And then every time you see an x, what are you going to put in that x spot? Just a few of you. Sometimes you might not leave yourself enough room in homework, right? So it's okay to have a whiteboard off to the side, or it's okay to have, because whiteboards are so much easier to like erase mistakes, not you have tons of room. Or it's okay to have use the next piece of paper. But then you can go ahead and do things like, okay, we got to keep going. PEMDAS says do what? Exponent, so -3. Now careful, some of you are going to make a mistake. -3 times -3, right? And negative times a negative, is that? And then I have -3 times -3 minus 4. Now it's time to do all my multiplying. I did my exponent, check, multiplying. Ugh. This multiplication is kind of easy. A -3 times a -3 is a positive 9. Why am I avoiding this guy? These are fractions. I mean, you guys do it too. You're like, I'll go do something else. Right? But put the 9 over the 1 and say, okay, whatever. Isn't it -9 over 2? Don't stress. But now why is it like something that you want to avoid? Yeah. But we can break it down to make it -4.5 if your brain likes that better. That's one way of doing it. And then you can add 9 and subtract 4. The other way of doing it is you could make common denominators with these guys. You can put them all together in one big grand fail swoop. So if the 4.5 thing doesn't work. Melissa, do you have a question? So then I end up with an 18 halves, and an 8 halves, and a -9 halves. If I can make them all halves, it's like, all right, I got it. -9 plus 18 is 9. 9 minus 8 is 1. Oh! Maybe that wasn't as bad as I thought. I put my whole numbers over 1s, and then I multiplied these little baby guys by 2 over 2 to make it a common denominator to be able to put them all together. Yeah, if you want to write yourself a note, you can write yourself common denominator question mark. That's something for us to talk about. Because it was a fraction, right? And there was like so many different places to plug in. Now wait, we're missing one piece to this problem. Y-intercept. Now, maybe we haven't talked about it today. You might want to do like a color pen or a highlighter kind of thing. But y-intercept, it might be helpful for you to remember that we talked about it yesterday. Adrian, hang in there. Jerry, hang in there. Y-intercept, all we got to do is plug in x is 0. Which 0 is like the easiest number ever to plug in. And some of you might be able to do it mental math if you understand that 0 is like the easiest guy to plug in. Because didn't you just see me leave spaces for what to plug in based on where the x's are, right? If I plug in a 0, the great thing about 0 is 0 squared times anything is always 0. So if I were to plug in, I'm just going to get a 0 minus a, hey, 0's times it. Sweet. 0, and then all the zeros go away, and all I have left is always going to be that C guy at the very, very, very end, which is kind of nice. Yes, we're plugging in 0, but basically for x-intercept, we always get to basically, for a quadratic, just take that number and say, I got him. 0, -0, -4. So I have my axis of symmetry, and the vertex, and I have my, here it is, y-intercept. Okay, I was kind of reviewing a few things that we did yesterday, but the reason why we're reviewing it is because there's a question coming in. Let me kind of rearrange these pages so we can see it. There's a question coming today that takes it one step further. Oh wait, we already did all that work, didn't we?
Yeah.
Oh, hey, look at me just giving you the, oh, I think it was on purpose. We know the axis of symmetry because we did all the work. We know the vertex because we did all the work. The y-intercept, it was so nice. 0, 0 minus 4 is just -4. So how do we take the clues and make a graph out of it? Well, we got some points, right? Jonathan, remember yesterday how many points to make a parabola? 3. And one of them needs to be the vertex. Good. I have my vertex, so plug it in. -3 and 1/2. Now, my graph should probably be zoomed in a little bit. I have not given myself very much room. Let's see if it's one of those cool ones I can actually change. Maybe not. Because why would I be going by 2s if my numbers are like 3 and a 4th and all that sort of stuff? Let me see if I can zoom in. Can I zoom in? There we go. That's better. Those units are a little bit better, yeah? So I'm going -3. Oh, maybe too much zooming in. I have -3 and 1/2, which is just a little bit there. I have 0, -4, which is way down. Whoa! What on earth does this guy look like? It's a parabola, but is it a concave up or a concave down?
Concave down.
Because he's a negative dude, right? Negative dudes are going to frown. So then, and this is the highest point? So what's the cool thing? If I know one side, you guys remember what parabolas always do? They copy on the other side of the vertex. That's why I want the vertex in the middle. If I have one side, all I got to do is flip it to the other side. So guess what? If I need to go over 3 and down, can't I go over here and also go down and copy the exact same point and be like,
Yes.
swoop, there it is, no table necessary. So now that we have this nifty formula, I know where my vertex is. Remember, he got shifted, he got moved. I know where he is, he's right there. The intercept will give me 1 point, flip it on the other side of the vertex, I have the other point, boom. Or if worse comes to worse, Jonathan, ready? I have 1, I have 2, all I need is 1 more.
3.
I need 3, right? So I have 1, I have 2, I need 3, I need 1 more. If we were to make a table, we could go ahead and say, okay, fine, if I have -3 in the middle and I have 0, well then I'm going to go to -6. I already know your answer, you're right there, I already know your answer, and it always copies with the vertex. What's on one side will be on the other side, as long as you make it equidistant. Oh, that's a snazzy vocab term. But as long as you make it the same distance on the other side. So all the stuff that we've been doing, basically little baby shortcuts to help us graph faster. Basically little baby shortcuts to help us graph faster. Now, there's just one more big idea that you guys might need in homework. Andrew, hold on and try to ask me right at the end, okay? What's the other big idea? Check it. What if these were homework directions? It says find the what? Either a parabola has a, what kind of value? Min. See it? Or a max. Who's this guy going to have just by looking at the 2? Is this a positive dude or a negative dude? Positive dude. What do positive people do?
Go up.
Smile. What do smiles have? I know it's weird. It's like backwards in our heads. I'm going to have a minimum. But where's the max or the min always going to be? What's the snazzy name for this point, whether he's on top or on bottom? Well, positive is going to have a bottom, but what's his name? It starts with a V and ends with a vertex, right?
Vertical.
All I have to do. That's how high you go. Vertex! Guess what? Do we already know how to find the vertex? Yeah. Could you write notes and be like, oh, hey, if you have a concave down, he's going to have a max. You could. If you're concave up, you're going to have a min. You could. Or you could just draw a picture and say, aha, you're a min, and where's the min at? Whoa, whoa, magic. Where am I getting all these numbers? It's the vertex formula. Nothing changes. You're just finding the vertex. You're just giving him a snazzy name based on the picture of a min. If you guys want, feel free. Grab a picture of this on your way out the door. Oh, I'm so sorry I didn't write it down. Homework is on RunWeb. If you want to wait 2 seconds, I have it right here to write down. 13 through 17, 21 to 22, and 27. You guys want to take a picture of it?
I need to take a picture of this. Wait, come here.
No.
Yes. Yes.
I know that's why it's hard.
Yeah.